Hey guys, Miss Varian here. Welcome to Unit 7 Notes 2. Today we're going to go ahead and we're going to talk about permutations. This is going to be a way that we're going to help to determine how many different ways or arrangements we have of something so that we can use it when finding probabilities later. So this first example here, we have the manager for a coffee shop who needs to hire 2 employees, one to work at the counter and one to work at the drive-through window. Katie, Bob, and Alicia all applied for the jobs. How many possible ways can the manager place them? And we're going to go ahead and we're going to make a list for this one. So we know that we have someone that needs to run the counter and someone that needs to run the drive-through window, so the window. So we could put Katie on the counter and Bob in the window, or we could put Katie on the counter and Alicia in the window. We could put Bob on the counter and Katie in the window, or Bob on the counter and Alicia in the window. We could do that one more time with Alicia on the counter and Bob in the window, or Alicia on the counter and Katie in the window. So each of these that you have here is a different way that we could pick 2 of these people to work the counter and the drive-through window out of the 3 of them that applied. So we have 6 different ways that we could place these 3 different people. So basically what we're looking at is we're looking at a permutation as an arrangement of the objects in which the order is important. So arrangement is going to be a really big thing that you're going to look for. When we're looking to arrange people, we're looking to put them in a specific order. So in this situation, order is very important. AB is different than BA. If you think back to that drive-through, working the counter versus working the window are very different things. So Katie working the counter and Bob working the window versus Bob working the counter and Katie working the window, those are 2 very different things. So that's a permutation that we're talking about. So we want to look at how many different arrangements there are for the letters in the word triangle. First thing that we need to find out is how many total letters are we dealing with. So we have 1, 2, 3, 4, 5, 6, 7, 8 different letters. So basically I have 8 different places, 3, 4, 5, 6, 7, 8. And I want to fill them all with a letter from the word triangle. So this is kind of what we were looking at yesterday. This is our 8 factorial. I have 8 options for the first one. Once I place a letter, I only have 7. And then I only have 6, 5, 4, 3, 2, 1. We can go ahead and we can multiply these out. I want you to make sure that you can find that factorial button on your calculator. So a fast way to plug this in here, instead of doing 8 times 7 times 6 times 5 times 4 all the way down to 1, you can hit the 8 and then find your PRB button. You want to arrow over until you're underlining the factorial and then hit enter. And then hit enter again. And that'll give you your answer right away. When I did this, I ended up getting 40,320 different arrangements for the letters in the word triangle. So now we want to determine how many different arrangements are there for the letters in the word triangle if I must put the first letter as A. So basically, I still have 8 letters that I am trying to place here. 7, 8, but the first one, this one right here, it has to be A. That's what I need in that spot. It has to be the A. Once I place that, it's not up there as an option for me anymore. So the first number I have here is actually 7 times 6, 5, 4, 3, 2, 1. Multiply those out. So this is pretty much looking like it's a 7 factorial situation. So see if you can find that button again and see if you can get an answer without having to type all that out. When I did it, I got 5,040 different arrangements. So now in Minnesota, license plates are made up of 6 characters. They have 3 letters and 3 numbers. We need to figure out how many different license plates we can make in the state of Minnesota. So we need 3 letters and then 3 numbers. So different letters. How many letters do I have to choose from? Well, think of how many letters are in the alphabet. I have 26, 26, and 26 because we can have repeats. I can have a license plate that has AAA. That is something that we could do. Then when I think of the numbers, how many different numbers do I have? I have 0 through 9, so I have 10 different options for numbers. And we can go and we can multiply these things together. When I do that, I got a bunch of different options. I have 17,576,000 different options for creating a license plate. Now here's what we have to remember. In Minnesota, it doesn't matter if the letters come first or the numbers come first. So I could also do 3 numbers and then 3 letters. This is still going to give me the same number, 506,000. So if I add those together, I'll get my total number of ways that I can create a license plate in Minnesota. And I ended up with 35,152,000 different plates. So let's actually look at this permutation formula that we're going to use here. You're going to see this NPR as our permutation. So N is our total number of objects, and R is the ones that we are using. The P just makes us recognize that as a permutation. That will change when we look at different types of notes here, but for today, it's always going to be a permutation formula. So what we're going to do with this is we're going to do the N factorial, so my total number factorial on the top, divided by the total minus the ones I'm using, factorial on the bottom. So I'm going to do an example here and see how this plays out. I want to evaluate 5P3. So that means I have 5 total, and I am going to use 3 of them or pick 3 of them. So my N is my 5. So I have 5 factorial divided by 5 minus 3 factorial. So I'm going to simplify that and get 5 factorial divided by 2 factorial. So we want to write that out. 5 factorial is 5 times 4 times 3 times 2 times 1. 2 factorial is 2 times 1. When we divide a number by itself, remember they kind of cancel out and you're left with just a 1. So I'm going to cancel anything out that's on top and on bottom. And I'm just going to be left with 5 times 4 times 3. When I do that in my calculator, I'm going to go ahead and I'm going to get 60 as my answer then. So I want you to pause the video. I want you to try to evaluate 7P2 on your own. Get an answer and then come back and check your work. So when I went through and evaluated this, I ended up getting 42. If you got anything different, please come chat with me before moving on to the next example here. So here's the example we're going to look at. Example number 7. We have 10 finalists in a figure skating competition, and we want to figure out how many different ways can gold, silver, and bronze medals be awarded. So in order to do this, I need to know my total. My total is going to go on top. And then my total minus, so total minus what I'm using or how many I'm picking on the bottom. So I know that my total is 10, so N is going to be 10. I have 10 total. And my R is going to be how many I'm picking. Well, I'm picking a gold, a silver, and a bronze, so I'm picking 3 of them. So I'm going to have this. I'm going to have 10P3, and I'm going to use my formula, and I'm going to do 10 factorial divided by 10 minus 3 factorial. So I'm going to get 10 factorial. 10 minus 3 is 7 factorial. So I'm going to write this out now. I'm going to have 10 times 9 times 8 times 7, 6, 5, 4, 3, 2, 1, divided by 7, 6, 5, 4, 3, 2, 1. Cancel things off. Kind of makes my situation a little nicer here. I have 10 times 9 times 8 left. When I do that, I am getting 720 ways that we can pick 3 people to win gold, silver, and bronze from 10 total. So here's my next example here. I have a newspaper that has 9 reporters available to cover 4 different stories. We want to figure out how many ways can the reporters be assigned to cover the stories. This is kind of a big word for us. We're going to use that word. And when you see assigned, it means that order is going to matter for us, so we know it's a permutation. So again, we're going to need to figure out our total and how many we're picking. So N is going to be my total. Well, I know that I have 9 reporters total. And I need my R to be how much I'm using. I'm going to do covering 4. So I'm going to have 9P4. Plug that in, I get 9 factorial divided by 9 minus 4 factorial. So I'm going to end up with 9 factorial divided by 5 factorial. We can write this all out. Now, if you're paying attention or kind of noticing something happen here, from this point on, the 5, 4, 3, 2, 1, all of that's going to cancel out with the 5, 4, 3, 2, 1 on the bottom. So we only really have 9 times 8 times 7 times 6. And when I plug that into my calculator, I get 3,024 different ways that we can assign 4 reporters out of a total 9. So example number 9 here, we have Miss Brisky asks pairs of students to read statements in Spanish and then translate them into English. If Miss Brisky chooses pairs from Jeff, Kathy, Chris, Anna, and Madison, in how many different ways can she pair the students? So I want you to pause the video and I want you to try this one on your own. Go ahead and come back when you're done. Check your answers before moving on to the next problem here. So when I did this problem, I ended up with 20 different ways that I can have 1, 2, 3, 4, 5 people total and pick them for pairs. So I want them in groups of 2, so I'll pick 2. So 20 different ways. If you got anything different, please come chat with me. Or if you don't understand where you went wrong, let's fix that before moving on.